which I'm proud to say is just started its 5th year. We'll let everybody get their seats. We have a good crowd tonight. And beloved President Jerry Wilson came down with something. It's not COVID, it's not even a virus. He just has a little health thing. And he will not be here, but I'm going to try to run the show as best I can and cover as much as I can. I always like to find out who's here, because it's dawning on me over the many years of having these First Friday meetings that this is not just a meeting for SBAU. It's a group gathering, a lot of strangers. I need you to raise your hand if you're here for the first time ever. We want to find out. Look at this. Whoa. Big hand for that. Yes. All right. And I'm the one that likes to find these things out. Who's been here before but is not a member? This is your secretary. Okay, we got some returns. We did something good. Now, the members, raise your hand. Proud guys, here we are. I must tell you on behalf of the club that we're a pretty friendly club. There's some great people in here. And it's only $20 to join. And for that, there's a June potluck. There's a mid-October lakeside camp out. There's an incredible meal in December. And there's these speakers. Our incredible speaker from Colorado is going to be up here in a few minutes. We've got to do a few things for our meeting first, so forgive me for taking up too much time. I just would like you folks that raise your hand third, the members, to look up the people that raise their hands first and second time at the end of the evening when we're socializing and get those guys. Take them to dinner. I have a beer. $20 is the price of a meal in Santa Barbara these days with a drink.
If you're lucky.
And tonight, what we're going to do, I'll get my glasses on. Going to go Martian hunting. The Beyond UFOs will be our subject in a few minutes. Scientific search for extraterrestrial life and its astonishing implications for our future. Just curious on my behalf, if some of our favorite members that if you do become a member, you'll get to proper meet and know they might be friends of yours, is our beloved astronomer who runs the department up at City College, Sean Kelly here. There he is. That's the man. He gave us a little shot of his own teaching skills last December. That's something else you get with the membership in SBAU. Every December we give it to 2 members. And our brand spanking new for the new year secretary, Tessa. Raise your hand, Tessa. Where are you? There she is. Let's talk about dark matter. Let me just real quickly.
Dark energy.
Oh.
Dark energy, yeah. I get those two confused. One's push, one's pull. And my partner keeps telling me they're not opposites. I'm the guy that doesn't know anything. I get to MC the Monday morning vlog we do. And I'm very proud of it. I'd like to introduce the guys if they're here. Jerry is the man behind it, really. Jerry Wilson, our president, so he's not here. I know Bruce Murdoch, who is also president of the Santa Barbara Theater Organ Society, is here. Raise your hand. Is Tim Crawford here? He's usually online, isn't he? He never comes to this. And of course, the beloved half of the duo that is pretty much the heart and soul of the club, my good friend Ben ran the show down at the Platinum Planetarium, Chuck McPartland, who will be here tomorrow with his pet rock. To make your foot be like a duck if you drop it. Come tomorrow night too. This is a rare time when we have, well, it was the same last month actually. It's actually 4 weeks ago. First Friday was followed by second Saturday. And who else is in the club? Let's see, besides Chuck and Bruce. Tom Whittemore, is he here? There he is. He edits our newsletter. He's the science better testimony. And I'm going to call Violet in a few minutes too to introduce our guest speaker after I tell you all about him. I just want to quickly, before I eat up any more time, give you an idea of what's to come. Coming attractions for Santa Barbara astronomical Astronomical Unit. Future meetings. April 4th, we've confirmed Joseph Farah, a young postdoc UCSB student who was involved in photographing using radio telescopes the supermassive black hole at the center of our galaxy, the Milky Way. It's called SAG-A. They call it a star. You just can't see it because it's collapsed. But the pictures are incredible, and he filled, believe it or not, several years ago, last time we had him here, I think it was either during or right before the pandemic, we overflowed Farron Hall, the smaller hall down below, right next to the planetarium where we had that speech. And the reason we overdid it then was that LCO, which he works at, National Scubas Observatories, they have telescopes around the world, and it's headquartered in Galena. And they put together a big promotional campaign that night, and man, it was crazy. We had over 100 people that taking place at Old 80. In case the fire marshal was here, you didn't hear that. We're going to have it again down there. But we're going to have to monitor the doors. And the minute we get whatever the capacity of Little Farron Hall is for Joseph's speech, sorry, I guess we sort of do that at the planetarium until we have, what, under 50 seats, 45 or so. So Joseph will be in here to give us an update next month on the SAG-A, and then March 2nd, I'm still waiting to hear back from Night Sky Network. Later on, in the summer, we have a young man who happens to be our president's godson, works for NASA, he's a scientist with a doctorate, controlled the Ingenuity helicopter that went with the latest rover to Mars. Perseverance had a little helicopter, believe it or not. He was the guy that Bennett talked about. He's coming here to talk to us in mid-July. June will be our big picnic. So, without further ado, let me read about what's happening tonight and then have Isla bring him on, if that's all right. Isla Jade Comasa is, where are you, Isla? Raise your hands so everybody can know you. Oh, you're waiting over here, all right. Dr. Bennett, I presume, he's here on behalf of the university and the museum, and we're lucky to have him. The man has taught science at every level, from preschool to graduate, written numerous books for kids, educators, college students, and the public. Dr. Bennett served 2 years, get this, as a visiting senior scientist at NASA headquarters. And he proposed and co-led development of the Voyage Scale Model Solar System, which is on the National Mall in Washington, D.C. I'd love to see pictures of that. I hope he has something to talk about on that. Created a free totality app for learning about solar eclipses, and Jeff made a free online textbook for middle school Earth and space science. His kids' books have been sent up to the ISS space station, read to the astronauts. He's won both the American Institute of Physics Science Communications Award in 2014 and the Klopstock Memorial Award in 2023, 2 years ago, for education from the American Association of Physics Teachers. Isla, will you come up and introduce our special guest?
You forgot to call on the other officers, so just really quickly, we have a bunch of AU merchandise here, if you'd like t-shirts with colorful things on them. And we were donated a bunch of really high-level quality astronomy books here that are free. I see some have gone already, but there's 4 left. And there's all kinds of astronomy propaganda here, starmaps, moon maps, and web pages. So thank you. Sorry, Ron.
Thanks. Sorry for me forgetting again, David. I have this pressure. Get to the speaker. I keep forgetting this is a meeting. Did Tessa, you didn't have anything you wanted to say, did you, for her?
Just reminding members, there are about 8 more directories, so get them while they're hot, but it's only members can purchase them. So if you want a directory, become a member, you can get them too.
Okay, and Chuck, did you mention the freebies out there on the table?
Yes.
Okay. Awesome.
Thanks. Hi everyone, my name is Isla. I do astronomy here at the museum. I see some familiar faces from our shows. You might have seen me around. And I help liaison with the AU. So I'm always here for any astronomy needs at the museum. But I just wanted to say a quick thank you to everyone for coming here today. Also a huge thank you to Dr. Jeff Bennett for making his trip out to Colorado, being here with us tonight, and also doing numerous events in our community to spread the love of astronomy. Just a couple other things to keep in mind if you have young children around or know any children interested in astronomy. Jeff is doing some more things here at the museum tomorrow morning. We have a 10 a.m. planetarium show and an 11 a.m. planetarium show where he'll be showcasing some of his children's books on astronomy. And then we also have one of our star parties tomorrow night. Ronnie spoke about it a little bit, but it's great weather out before it gets too hot or too cold or too late. So we're in pretty good timing right now. Our star party will be tomorrow night, free, open to the public observing. We have lots of amazing telescopes and lots of fun things to see in space. So come out to that, and also, as always, check out all of our astronomy events here at the museum. We do lots. And Ali, our events manager over there by the door, has a table set up where you can hear a little bit more about becoming a member here at the museum and some of our non-astronomy related events at the museum as well, which we do have awesome non-astronomy related events as well. So if you stop by Ali's table on your way out, she can give you some more information about that. I'm here as well if you guys have any questions. And without further ado, what we're all actually here for, Dr. Jeff Bennett.
All right, now I have to figure out how to share my screen here so you can actually see the presentation. So let's see what happens.
Takes like 8. Give them 10 seconds.
Yeah. It likes a little time. There we go. Oh, look at that. Thank you very much for having me here at the museum, and thanks especially to Isla for setting everything up for me. I told her earlier tonight, she gave me the most organized schedule for where I needed to be and everything else that I was doing these days. I really appreciate it. So everybody, a big hand for that. And I'm really pleased to be here. So the connection is my daughter went to UCSB. She graduated a year and a half ago. And my wife and I really loved coming to Santa Barbara to visit her while she was going to school here. And then she graduated. We're like, well, how are we going to get out there again? And so thanks to Ilo, we had a good excuse to come for this trip. So what I want to talk about tonight is this topic I call Beyond UFOs, the scientific search for extraterrestrial life, and its astonishing implications for our future. Oh, I can't change that because otherwise I can't see what's coming next. Sorry. It's a Zoom flaw. They don't have presenter mode in Zoom for some reason. If those who do PowerPoints know what I'm talking about. Anyway, so what I want to talk to you about, well, what is beyond UFOs? Well, hopefully that'll become clear as we go along. But the short answer is what's beyond UFOs is science. And so we're going to talk about the scientific search for extraterrestrial life. But my other big goal tonight is to convince you that this does, in fact, have astonishing implications for our future, and I'll show you how. This will work better if I turn it on. See? When we talk about aliens or UFOs or whatever, this is kind of the images that most people come to mind for most people. This is what you might call a modern view of aliens. A modern view of aliens. And a lot of people think that this idea of aliens is in fact a pretty modern idea, but it turns out it's not. People have actually been talking about about aliens for a very, very long time. And to show you that this is the case, I have a couple of quotes here going back more than 2,000 years. And you can see the first one here from Epicurus at about 300 BC. He said, "There are infinite worlds, both like and unlike this world of ours. In all worlds, there are living creatures and plants and other things that we see in this world." So here you have somebody almost 2,500 years ago saying, not only asking whether aliens exist, but basically saying they do. There's all kinds of worlds out there with aliens on them. But that wasn't accepted by everyone, and you can see a counterpoint idea coming from Aristotle. His quote's a lot shorter. The world must be unique, basically saying, there is no other place like this with the kinds of things we see in this world and so on. And you might wonder, why, more than 2,000 years ago, were they having this kind of debate, and how did they come to such diametrically opposed conclusions about what was going on? And so for those of you who know a little bit about ancient Greeks and the philosophers there, you may know that Epicurus was one of a group that was known as the atomists. Democritus is probably the more famous name among the atomists. And these people believed, well, pretty much all of the Greek scholars thought that the world consisted of 4 elements: fire, water, earth, and air. But they had different ideas about the nature of those elements. The atomists believed that the elements could be broken down to a smallest size, individual atoms, the word we still use today. Aristotle didn't buy that. He didn't believe in atoms, although he did still agree with the same 4 elements. And we'll come back to his ideas in a moment. But so, for Epicurus and the atomists, they had this idea about how the earth came to be. And their idea basically was that the universe began with an infinite number of atoms of the 4 types. And they imagined the 4 types had characteristics. So, for example, fire atoms were spiky, which is why fire hurts, right? And water atoms were round, which is why water flows. And earth atoms were like 3-dimensional jigsaw pieces. So if they banged into each other just right, they would stick. And so they imagined that the universe began with this infinite number of atoms, and the way the earth formed was a whole bunch of earth atoms came together and stuck and made the earth. Well, if there's an infinite number of atoms, and we got the earth made here, the same thing must have also happened an infinite number of other times in other places. And therefore, there must be infinite worlds, just like ours. So a natural consequence of the way they imagine the universe forming. Aristotle's got a different idea. He doesn't focus on the nature of the atoms, he focuses on forces. And so his idea is that, the key force is gravity, and that the 4 atoms, according to him, have different weights. Earth is the heaviest, and therefore gravity pulls it towards the center, and then the water comes on top of that, and the air and the fire. Right? But if that's your conception of the universe, gravity pulls everything towards the center, that means all the earth in the universe must have fallen to the center, which is where we are, the center of the universe. And there couldn't possibly be any other worlds, because if there were, they would have fallen to here. So now you see how they got these 2 ideas. And this debate was actually it was a huge debate in ancient times, and it continued. If you look at the history of, for example, the Catholic Church, you will find this being debated throughout the entire history of the church. St. Thomas Aquinas, other famous priests like that, all weighed in on this debate and had their own opinions of it. And in fact, the debate continued pretty much unchanged for close to 2,000 years. And you might wonder, why did the debate continue unchanged for close to 2,000 years? And the answer is really pretty simple. It's because it's easy to keep arguing endlessly as long as you don't have any facts to get in the way. And this is where the science comes in, right? What is science about? Science is about trying to bring the facts to bear on our debates. And in particular, I like to think of science as having basically two purposes. The first is that science is a way of distinguishing possibilities from realities. So you can, just guess, hypothesize, whatever, all you want, come up with all kinds of possibilities, but most of them aren't going to be real. How are you going to know which ones are real? That's what science can do for us. And the second thing is that science can bring us to agreement if we get enough facts to tell us which possibilities might be real. And in this particular debate that went back for a long time, there were no facts until about 400 years ago. About 400 years ago, with the Copernican revolution, we learned that Earth is not the center of the universe. It is a planet going around the sun. So if you think back to our debate, we had, in that case, two possibilities. Epicurus' infinite worlds, and Aristotle's no, we're the center and this is where everything is. Well, as soon as we find out that Earth is actually a planet going around the sun and not the center of the universe, that means Aristotle's possibility is wrong. That one we can rule out now. At least on his basic reason for thinking that this world had to be the only one. And so we now know that that one's out. Now, interestingly, when that happened 400 years ago, by and large, most of the scientists around that time said, well, gosh, if Aristotle was wrong, basically that means Democritus is right. And they kind of concluded there was life all over the place. William Herschel, famous discoverer of Uranus, he imagined there was life on every world in the solar system, including the sun. This was a common belief, life all over the place. But of course, those are not the only two possibilities. There's a lot in between 0 and infinite. But you can kind of see how this process goes. But the other part is, remember, we've distinguished, at least in one case, a possibility that is not reality, Aristotle's. But then there's also this part about helping people come to agreement. And remember, this idea that maybe the Earth is a planet going around the sun was not new 400 years ago. It had been proposed back in ancient times. Aristarchus famously proposed this idea around the same time as those quotes that I was giving you. But people didn't have any way to tell whether Earth was the center of the universe or not the center of the universe, and instead a planet going around the sun. So for 2,000 years, there were people on either side of this argument. Most of them coming down on the side of the center of the universe, but not all of them. Leonardo da Vinci, for example, famously figured out or thought that the Earth was a planet going around the sun. Unfortunately, he wrote that in code, so nobody else realized he was thinking it until much later. But then, about 400 years ago, Kepler, Galileo, Newton, in a very short amount of time, come up with so much evidence proving that Earth is a planet going around the sun that everybody came to agreement on this point. So science brought us to agreement. So I want you to keep that in mind, because oftentimes we'll hear people say science is divisive or contentious or everything else. But really at its root, science is a way of bringing us to agreement as long as we all look at the same facts together, which can be a challenge, and think about them, then we can come to the same answers. And so with that, I want to turn more specifically to the science of extraterrestrial life today. And the question of, is there life out there beyond Earth? Of course, we don't know the answer to this yet. But we can think about it in a fairly simple, organized way, and I like to start out with the idea that even aliens need a place to call home. And the reason I say that is because basically, from what we know about science today and the universe, the idea that aliens might appear spontaneously in interstellar space just does not seem reasonable. If there is alien life, it seems like it has to start on a planet. There has to be a home for that alien life, a planet. So if we're going to be looking for alien life, we're going to start that with our planetary context. The question of, are planets that could have life on them common or not? And then the next question is going to be, well, if, and you can see right there, I've said planets are common, but I'll give you some data on that in a moment. The next question is going to be, okay, if you have a planet where you could, in principle, have life, do you have life? That's the biological context. On this planet, we got life, but would that necessarily have happened on another place that was like the Earth? And then the last part is, once you get to those first two, if you think there's a good possibility of life, how much life would there be? And that gets to the astronomical context of how many stars and places there might be to look. So let's just go through each of these very briefly. So let's start with that planetary context. Only about 30 years ago, we did not know of any planets around other stars. The 8 planets in our solar system were the only ones known, although at that time they said 9. One got kicked out. But it's actually still out there. It hasn't changed a bit. Only our name for it changed. Well, the name or category for it changed. But in the last 30 years, astronomers have now discovered already more than 5,000 planets around other stars. And based on the techniques that are used, which I don't have time to go into tonight, but you can actually do some statistical analysis on this. Basically, how many stars could we in principle be detecting them around? How many have we detected them around? And when you do that, you find the vast majority of stars, at least 70% or so, and probably over 90% have planets. And then you can also start to do statistics on how many stars have planets of various sizes and so forth. And these are all minimums based on the statistics today. So for example, planets the size of Earth, at least about 17% of stars have one. The real number is probably much, much higher than that. But already we're seeing planets the size of Earth are pretty common. We know that. And it also turns out to be pretty common for them to have orbits around their star, in which in principle they could have Earth-like temperatures. So I like to think of these as Earth-ish planets. From what we know about them, which is very, very little, right? We know mass and orbit, and that's about it. From what we know about them, it seems possible that they could be like Earth in terms of oceans, atmosphere, and things like that. We don't know for sure, but it's at least possible. And so our planetary context, we have the answer. Planets that could in principle be home to life seem to be common. So the next question is that biological context. If you have a planet that does have conditions that could allow for life, are you going to get life? And we do not know the answer to that. And we can't do statistics on it really either, because we only have this one planet to go from. But we can look at some data to get a handle at it. And we can do this in 2 ways. One is you can look in the laboratory and try to understand how did life get started. And it turns out, based on what we think we know today about the early Earth and the laboratory experiments, it seems like all the ingredients for life were here, and that natural chemical processes tend to point in the direction of getting life. But we can't prove that for sure because no life has crawled out of a test tube yet. But there's enough complex organic chemicals that we see forming naturally that it seems like, yeah, it does seem like it wouldn't be that hard to get life started on a planet like Earth. And now you can look at the geological data. So this is a timeline for Earth, the present here, going all the way back to Earth's formation 4.5 billion years ago. And if you look at this, you'll notice there's this red bar here that says the heavy bombardment. And what is that? Well, so when the Earth first formed, the solar system was messy. So there were a lot of big things hitting the Earth. You know, right back in, I don't have it on this graph, but right near that 4.5 billion years when the Earth first formed, we think something as big as Mars hit the Earth and basically spit out the moon, right? And it formed in orbit around the Earth. And over that period indicated by that red bar, it seems statistically very likely that Earth was every few million years getting hit by something quite big. So big that it would have completely vaporized the oceans, melted the crust, which means if there was any life on Earth, it probably would have been killed off completely. So basically, during this period of the heavy bombardment, it's possible that Earth got life, but if it did, it probably got knocked off, and it had to start all over again. And so it's not until close to the 4 billion year mark where it first seems like it's possible for life to take hold. The reason being because we're not going to get hit by any more of those really big things. Why? Because they all hit somewhere already. There's none of them left. And the oldest evidence of life on Earth is right at that time, fossil evidence of life. So in other words, it appears from the geological record that almost immediately from the time that it was possible for life to take hold on Earth, it did. What does that prove? Nothing. However, it's suggestive, right? If it was really difficult for life to get started, you might have expected it to take a long time. If it was easy, then it would have happened fast. And it did happen fast. And that combined with the laboratory experiments makes us have pretty good reason to think, you know, if you've got the right conditions, seems pretty high probability you're going to get life. Now that could all be wrong because we don't have the proof on either case. But certainly from a likelihood standpoint, most scientists would tell you they think if you've got a planet with Earth-like conditions, you're probably going to get life on it. So how much life is out there? Well, let's start with our galaxy. Maybe I shouldn't distract you with this photo yet. Let's start with our galaxy, the Milky Way galaxy. The Milky Way galaxy has somewhere between 100 billion and a trillion stars in it. We'll just call it 100 billion to make it easy, but we'll keep that bigger number in mind, because that means if we just say, you know, somewhere between 10% and 100% of stars have an Earth-ish planet around them, then regardless of which number I pick, I can still say 100 billion planets that are like Earth in our Milky Way galaxy. So that's it, 100 billion planets. Kind of like Earth in our Milky Way galaxy. That's our number of possibilities for life in the galaxy. And then you're thinking, okay, well, it sounds like a lot. How big is 100 billion? So maybe after you go home tonight, you'll be thinking about this and, you know, you have trouble falling asleep, and so you think, well, I should count sheep. But don't count stars. Okay, so 1, 2, 3. How long is it going to take you to get to 100 billion? It depends, of course, on how fast you count. It's pretty easy to count a rate of 1 per second when I'm at 11, 12, 13, but it gets tougher when you get up to 48,969,345,192. So you can see that if you could actually keep up a rate of 1 per second, that would be pretty good. And if that was the case, it would take you 100 billion seconds to get to count your 100 billion stars or planets. And you know, you can check my math later, but it's very easy, right? You divide by 60 for minutes, by 60 again for hours, by 24 for days, by 365 for years, And you'll find out that 100 billion seconds is around 3,200 years. So if you decide to count the 100 billion stars, get started right away. Don't take any breaks, don't fall asleep, and very, very important, don't die. Otherwise you'll never get there. And that's just to count them, not to actually name them, point a telescope and see which one actually is Earth-like and which one actually has like, just to count the number of possible places with life in our solar system, and to me, in our galaxy, would take you more than 3,000 years. And then, that's just our galaxy, there's also 100 billion galaxies or more in the universe. So if you put those two things together, now you get the picture. The number of stars in the observable universe, which you can also, as we talked about, think of as the number of possible planets that could have life in the observable universe, is as many as all the grains of sand, not just here, but on every beach on Earth put together. The number of possible places with life in the universe is as big as the number of grains of sand on all the beaches on Earth put together. So now you ask yourself, is it possible that we're the only ones? Yes, it is possible. However, that's like there being one grain out of all the beaches on Earth put together that for some reason is different from every other one. Starts to become a little hard to imagine that that's the case. However, so far we don't know the answer to that question, and we'll come back to it. But first, I do need to acknowledge that there are people who think we do know the answer to this question because there's aliens here among us, or at least visiting quite often. Now, I don't know if UFOs are real. I have seen one myself. I'm not convinced. It was definitely unidentified because I don't know what it was, but I'm not convinced that means it was an alien spaceship. But some people are convinced. And so I can't really comment on whether UFOs are real or not, and what people see. If somebody says they saw something, it's not my place to doubt them, right? But what I can say is from science, I do know something about aliens if they are actually visiting us in UFOs. What do I know about aliens if they're visiting us in UFOs? Well, actually, I really only know one thing, but I know it for two reasons. The one thing I know is that they're really, really smart. And how do I know? Well, the first is because they come from really, really far away. What do I mean by that? Well, we've by now taken photographs of all the major planets and moons in our solar system. If there were any cities out there, we would already have seen them. That means if aliens are visiting us in UFOs, they don't come from around here. They come from the stars. And one of the things Ronnie mentioned that I've done in my career is build scale models of the solar system. We like to build our scale models on a scale of 1 to 10 billion. So there is the sun at 1/10 billion for the actual size, right? The size of a big grapefruit. On that scale, Earth is smaller than the ballpoint in a pen, and it's located 15 meters away over here in a glass disc. And then you can walk over to Mars, and you can keep walking about a third of a mile down to Pluto, which is in the model solar system because it's still real, it still exists, even though we don't call it a planet anymore. Incidentally, we have these in a couple dozen places around the country now, and I was telling you maybe you might get one here in Santa Barbara sometime soon, which would be fun to walk through. But in any case, on this scale, you can imagine that 15 meters. So if I put the sun over there, right, grapefruit-sized sun over by that wall, 15 meters away, somewhere over here, is my little ballpoint-sized Earth on the tip of my finger, imagine it. And then you say, okay, so where's the moon on this scale? Well, it turns out this scale, the moon, which is smaller than Earth, is only that far away. That's the distance from the Earth to the Moon on this scale. That, on this scale, is the farthest a human being has ever traveled. And only a few people did that more than 50 years ago with the Apollo program. Our spacecraft have gone all the way out the third of the mile to Pluto. And then you're thinking, okay, the aliens, they're coming from the stars. Where are the stars? On this scale, the next star, Alpha Centauri, is about 2,700 miles away. The distance across the United States. So you can walk to Pluto in a few minutes, but you'd have to cross the United States to get to the next star. According to UFO reports, aliens coming from those places are coming here easily and often. Which means their technology is so good that they can do the equivalent of going back and forth across the United States when this is the farthest we've ever gone. That tells you something about their level of technology compared to ours. And the second way I know it is because actually I can use a different kind of argument to say they're at least about 50,000 years ahead of us. I'm going to go through this one very quickly with you. But basically, the universe is about 14 billion years old. Our solar system's only been around for 4.5 billion years, which means there were other stars and planets that had as much as about a 10 billion year head start on us. And so as far as we know, for at least 5 billion years before our solar system was even born, it could have been possible for other Earth-like planets and civilizations to have arisen. And so now you can just play with numbers, and this is just a wild guess right here, I'll acknowledge that, but here's how I get to it. Imagine that 1 out of a million stars ends up with a civilization around it at some point. That's pretty low odds, right? 1 out of a million. But remember, there's 100 billion stars in the Milky Way galaxy. If you divide 100 billion by a million, you find that would mean 1 out of a million having a civilization. That gives us 100,000 civilizations just in this galaxy. But they could have been coming up anytime over the last 5 billion years. So you assume it's random, divide your 100,000 civilizations by the 5 billion years, and you find out that you get a new civilization arising somewhere in our galaxy about once every 50,000 years. So based on that average, that means, if these numbers are anywhere in the right realm, that we are certainly the newest, and therefore the dumbest and most technologically backward of all the civilizations in the Milky Way galaxy. And the next newest is 50,000 years ahead of us. And the next one after that, 100,000 years, and so on. And so all you have to do if you want to understand alien technology is think about what our technology will look like in 50,000 years if we keep going. Nobody even predicted the internet 50 years before it came along the line, let alone predict 500 years or 5,000 years or 50,000 years. And in fact, to try to understand what these aliens are capable of, I always fall back on one of my favorite quotes from Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. So basically, what I'm telling you scientifically is that if aliens are in fact visiting us in UFOs, their science is so good that to us it looks like magic. So imagine that they are visiting us and they want to tell us that they're here. They want to say hello. How would they do it? I don't know. They're so far advanced, I have no idea what they would do. But I'm pretty sure they could come up with something better than that. And that's why we have to go beyond UFOs, right? Because what I think is that if aliens are visiting us and they want to tell us that they're here, they can figure out a way that'll get through to us. And if they don't want to tell us that they're here, they're like magic. We're not going to find out. And therefore, we can look at UFOs all we want. I don't think we're going to learn anything that way. But if we do science, we have a chance to actually learn something about them if they're real, and about life more generally in the universe. And so with that, I want to get into our search for extraterrestrial life a little bit more in depth, but quickly. And so the way we begin the search for extraterrestrial life is we have to first understand life on Earth. And one of the really interesting discoveries of the last half century or so is that we are not even, right, we know we're not the center of the universe, we're not even the center of Earth's biological universe. We're just part of one tiny branch of three major domains of life. Most life on Earth is not like us. In fact, if we were to destroy ourselves, most life on Earth wouldn't even notice. Now, we might take a lot of other animals and plants with us, but all these other microscopic things, they're just going to go on just fine. Just fine. We're not even the center of our own biological universe. And that means if we start out by looking for stuff like us, we're going to be missing a lot of the picture. So what are we looking for? We're looking for life more generally. And how do we look for life more generally? Well, we have to understand the range of conditions in which we find life, and there's a couple pictures showing you that, there's life living here in water that's superheated above the normal boiling point, which would kill us, but there's life forms that like it. Same in these hot springs in Yellowstone and stuff. There's even life forms that live inside the cores of nuclear reactors. They like it there. We would die instantly, but they're comfortable. There's all kinds of life. And in fact, there's really only one thing that all life on Earth seems to need, and that is liquid water. And therefore, if we're looking for life in a more general way, a good way to start searching is to look for liquid water, and maybe if you want to broaden your horizons, maybe some other liquid that could potentially allow life to thrive. And it turns out that actually isn't all that limiting. Even right here in our own solar system, we have quite a few places where we think there's either liquid water or liquid of some type that might, in principle, allow for life. Not a civilization like we have, but microscopic life. So Mars, Europa, and also Ganymede and Callisto, those are all moons of Jupiter. Saturn's moons, Titan and Enceladus, and more. Do any of these places have life? Well, we don't know yet, but the possibilities are really intriguing. I won't go into any details, but the reasons we're sending so many spacecraft to Mars, and scientists are so interested in Mars, is because of the possibility that it may have been home to life in the past, because it's got dried up riverbeds, deltas, and so on. This is where the Perseverance rover is exploring this area right now. Which means there was a time when Mars had a lot of liquid water on its surface. It does not anymore. But maybe life got started back at that time. So maybe we'll find fossil evidence of past life on Mars. Or there could still be some water underground. Maybe there's still microbes living underground on Mars. A little bit more of the data, but I won't spend time on it right now. I will tell you the question of, is there life on Mars? We do not know the answer to, but since I write some books for kids that are fictional, I get to choose the answers. And there's my dog Max finding life on Mars. He sniffed it out from the underground water, the microbes down there in the water. So maybe there is life on Mars. Europa, another great place to look for life. Europa is this ice-crusted moon of Jupiter, but based on data from our spacecraft studies, it appears that Europa probably has a big ocean of liquid water under its ice. If that's the case, Europa actually has more ocean water than Earth does. And it probably has undersea volcanoes at the bottom of that ocean, which means it would seem to have all the ingredients for potentially having life in the European Ocean. We're trying to learn more about that. The Europa Clipper mission, which launched last October, is on its way to Europa. I think it gets there in 2030 to try to learn more about the possibilities of life there. Well, again, since I write fictional books, I get to send my dog Max over there, and he found this spot where, accidentally while he was following a soccer ball, and they brought their submarine over and they melted down through the ice, and guess what they found underneath the ice on Europa? Life. So, of course, that's fiction, but if I had a bet, I would bet we're going to find life wherever we find water. But I don't know that for sure. Titan doesn't have, it's a moon of Saturn, 1 billion miles away. It doesn't have any liquid water, it's too cold. But it does have liquid methane and ethane. Maybe those are substances that could allow for life. So perhaps there's life on Titan of a very different type than life on Earth. However, as I mentioned earlier, this would be very simple, microscopic or simple forms of life that we find in our solar system. If we want to talk to somebody, we're going to have to look out to the stars. And unfortunately, our current technology is not capable of determining whether there's life on planets around other stars. We might be getting close, maybe in a couple of decades. We'll have instruments that could look for biosignatures and atmospheres of planets around other stars. But for now, the only way we know of to search for actual life on planets around other stars is through something called a search for extraterrestrial intelligence, SETI, where you're basically listening to see if anybody is sending us a signal to say hello. Now, one of the issues that you might think of with SETI is, well, gosh, what if there's lots of civilizations and they're all listening, but nobody's talking? So we talk, not often. But here's the message that we sent from the Arecibo radio telescope, digitally coded so that if they know prime numbers, which they obviously would, they could figure out that, this is the spacecraft that we have. This is the solar system. It's unfortunately got 9 planets in it, so they're going to be very confused. The person and so on. And they could, if they got this message, they would realize somebody smart sent it out there. And we have not heard a response back to this message. It was sent in 1972, and you might be thinking, well, that's a long time to wait for a response. But it turns out, to up the odds that somebody would get the message, instead of sending it at 1 star that we just picked, we sent it at a group of 100,000 stars, a globular cluster. That's about 21,000 light years away. So therefore, they won't get this message until about 21,000 years from now. And so if they answer, we'll get the answer at 42,000 years. So not so surprising that we haven't gotten an answer yet. But in any case, if you just think about everything we've talked about so far, I've said lots of planets, lots of possible places for life to be. Seems like planets that are potentially home to life should get life. Seems like even if it's only 1 in a million that ever get to the point of having a civilization like us, you're still going to have all kinds of civilizations out there. And you might start to think, gosh, how come we don't know about them yet? And this is actually a question that scientists have talked about for a long time. We even have a name for it. Where is everybody? Also known as the Fermi paradox, because in 1950, the famous physicist Enrico Fermi was sitting around with some colleagues, and they were talking about this very thing, and Fermi goes, well, wait, if all that's true, where is everybody? So we call it the Fermi paradox. And you can look up answers to where is everybody? Why, if life is as common as it seems like it ought to be, have we not actually gotten proof that that's the case? And you can find hundreds of possible answers to that question, but I think you could break them down into 3 basic categories. And when I show you these categories, you're going to start to see why there are astonishing implications for our future, because all 3 of them are quite philosophically profound. Because the first basic category of answer is that despite the fact that it seems like there should be a lot of life and civilizations out there, not the case. It's just us. We are basically alone in the universe, or at least in the galaxy. That is a possible answer to the question of why we don't have proof of other life, because it's not out there. At least advanced civilizations are not out there. Of course, if you think back to what we talked about before, that means we're the one grain of sand, which seems kind of hard to believe, although not impossible. But that's certainly one possible answer. Why does this have astonishing implications for our future? Well, this one's the most philosophical of them, so you have to bear with me for a little bit. If you talk to theologians or philosophers and you ask them what's the purpose of life, obviously you're going to get lots of different answers depending on who you talk to, but I would say there's usually a common theme across all religions and cultures and philosophies, and that common theme is that the purpose of life is self-awareness. Right? We should become self-aware of what we are and what our lives mean. And if you take that idea and you extend it to the universe, then you might say the purpose of the universe is self-awareness. And then you think, okay, so for 14 billion years, the universe was out there doing stuff, and it had no idea that it existed until we came along. We know the universe exists. We're part of the universe, and therefore we are self-awareness for the universe. And if we're the only ones in the universe, that means we're the only thing that makes the universe achieve its purpose of self-awareness. So if we were to destroy ourselves, obviously that would be bad for us. But we would also be wrecking something the universe worked for 14 billion years to finally achieve. Which I think maybe you can agree with me, that's the kind of responsibility we don't want on our shoulders. So don't ruin the universe's self-awareness if this is the answer to our Fermi paradox. Okay, that's one possible answer, but it doesn't seem very likely based on these statistics. So if that's not the answer, if we're not alone, then what's another possible answer to why we don't have any evidence of these other civilizations? Well, now you could say, well, maybe there's 2 civilizations, or 4, or whatever, but that's pretty unlikely. It's either going to be that life is so hard to get a civilization that we're the only ones, or else it's pretty easy and there's life and civilizations all over the place. And if there's life and civilizations all over the place, how can it be that we don't know about them yet? Well, possibility number 2 is they don't go out and colonize the galaxy. They just stay at home or never leave home. But then you have to answer, why would that be the case? Why would 100,000 civilizations that have had big head starts on us, some cases millions or billions of years, why wouldn't they have gone out and colonized the galaxy at some point? Sometimes people say, well, they just don't feel like it. But that's making us the center of the universe again, right? That's imagining that we're somehow different from other life forms. If other life forms are like us, then just like us, they like to explore. And I would tell you, if we survive, we're going to colonize the galaxy. It's just the way human beings are. It'll happen. Which means if they survived, they should have colonized the galaxy. So if they didn't, maybe it's because they didn't make it. Maybe, whether it's global warming, nuclear weapons, intolerance, whatever other thing you think of, maybe it turns out that when you reach our level of technology, you end up destroying yourselves, your civilization, so that you never get farther. Maybe all 100,000 civilizations or whatever like that just didn't make it. They never got far enough past this point where we are today to survive. And that's a real possibility. It brings me to my favorite quote of all that I use on my signature lines for my emails from H.G. Wells a little over 100 years ago. Human history becomes more and more a race between education and catastrophe. because if we're going to get through this, we have to understand what we're dealing with and chart that path forward. Now, if you think about this answer that nobody has survived, given what we know about our current civilization, it doesn't seem that hard to believe that this might be the correct answer to the Fermi paradox. However, we just hope not. Because if nobody else ever made it, it makes our chances look pretty rough, right? So we're hoping this is the wrong answer. So let's go back to where we are. First possible answer, it's just us. Could be, but sure seems unlikely. Second possible answer, civilizations don't make it much past where we are now. Certainly possible, but we don't like that answer. What's left? Well, what's left is they do get to the point where we are. They do figure it out. They do colonize the galaxy, which would mean they're already out there. So the third possibility is there is already a galactic civilization, one that probably predates us by millions or billions of years. If any of you remember Carl Sagan's novel and movie Contact, that was the premise in it. But what I'm telling you as a scientist is that I think the most likely answer to why we don't have evidence is because they're already out there and they just haven't yet chosen to let us know.
Yes.
Star Trek's Prime Directive, for those of you who remember that. Which means that sometime in the future, if we survive, we're going to meet up with them. And we'll be meeting up. It'll be like babies finding out that there's adults in the world. Pretty profound, right? I told you there's astonishing implications for our future because no matter which of these three possibilities is the right one, it's got astonishing implications. And what that means is that whatever the answer is, we happen to be living at the turning point of a civilization. All civilizations must go through this. They must reach a point like ours where they have the technology to, in principle, go out to the stars, but they could also destroy themselves with that technology. And therefore, we're in that position right now. We can either destroy ourselves or we can figure it out. And if we figure it out, we're going to be charting a path that means our descendants will eventually go to the stars, either as the first ones, if we're alone, or to join up with a galactic civilization that's already out there. And that brings me to the final question. Will we prove that there is intelligent life on Earth? So thank you. If you want to learn more about this, I would encourage you to read one of my books here on this topic. So I have a book, Beyond UFOs, which is obviously in more depth than we covered in the hour here, but written for the general public. And then I also have a college textbook, Life in the Universe. If you want to get into the more details of the chemistry and geology and so on, you can read that. And those are some of the rest of my books, the kids' books over there. And I think we have some time for questions. Great.
I can take some
Thank you.
questions if you want to raise your hand. I'll bring around the microphone.
Is another possibility for why we might not be seeing evidence of other life forms, other civilizations, and you mentioned a galactic civilization, is simply that the distances are so vast.
You know, that's a really interesting question. My personal answer to that would be I don't think so. The distances are vast, and the idea, with the scale we talked about of traveling to the stars is way, way beyond us technologically. But it doesn't seem like an unsolvable problem, because there's in fact two general ways to solve that problem. One is faster rockets, right? Build technologies that can get closer to the speed of light so that you can make these journeys. The other is medical science, right? Like if you go 1% the speed of light, and we can imagine easily technologies that we can do that with even now, nuclear rockets and so on. If you just go like 1% of the speed of light, you'll get to Alpha Centauri in 40 years. So an 80-year round trip, and you think, well, who's going to want to do that? Well, imagine we extend lifespans so that people live for 1,000 years. Then an 80-year trip might not be such a big deal, right? So there's a couple different ways of imagining how we could, in principle, do travel among the stars. And so even at relatively low speeds, given tens of thousands of years that they have a head start, or millions of years or billions of years, I think we'd figure it out. But, it's obviously debatable, and some people think maybe that is the big challenge.
I was going to say, since they are quite a bit more advanced, I would say, have you gone out to your backyard and tried to contact any of the bacteria?
Excellent question. Maybe it's not that they're deliberately hiding from us, it's just we just don't seem worth the effort. Could be.
Hi, Jeff. So I'm trying to get an idea of your certainty about how much you think life is out there. And I was thinking, when you're talking about there's so many planets out there, so many Earth-like planets out there, and it seems to be so easy for life to start. And I was thinking, say at the end of this talk, I walk outside and a plane falls down on my head and kills me. It's like so unlikely to happen that you just say it's not going to happen. And so for this thing, it's like, it's so likely that there is life out there that we should just say there is life out there? Or is it something you're hopeful that is true, or is it just true, you think?
Yeah, well, I think based on what we have the evidence now, I would say it seems like life should be very common, but we can't prove it, right? So we really don't know the answer to that question. And it turns out there are a group of people who go by something called the rare earth hypothesis. They tend to think that civilizations are going to be very, very rare. But even they don't usually claim that life is going to be rare. They claim that getting life to our point is going to be very, very rare. And there's actually a number of reasons why you might think that. And the easiest one to think about is the geological evidence that I showed you, right? Life got started on Earth very quickly. That's suggestive of the idea that it's easy. But it took 4 billion years before it got smart enough to start studying this stuff. That's a really long time, which suggests maybe getting to this stage is really hard. So the real question is the 4 billion years it took for life to evolve from its most primitive state to thinking beings, is 4 billion years, were we fast? Were we slow, or are we average? If we're average, then there's going to be civilizations all over the place because there's plenty of worlds that live that long. If we were fast and the average is 100 times that, then civilizations are going to be super rare. Or if there's other things that interfere with evolution on most other worlds. So that's where the kind of debates on this stuff come in. My own personal viewpoint on it is that every time in history that we've tried to imagine there's something special about us, we've eventually found out, nah, we're not. And I think that's going to be the case here too, but I can't prove it.
So I had two questions. The first was a few years ago, there was a Senate hearing, and some people talked to Congress under oath, and they said a few things and talked about the aliens, and they said that the government has biological and alien craft. And one of the people saying this was David Gersh, And this entire talk you've been giving has been under the assumption humans do not know whether aliens exist. So by saying that you do not know whether aliens exist, are you calling David Gersh a liar? And if so, on what basis do you have to say he's a liar?
No, I don't know what his motivations are or what he's seen, but I believe in his case, even he said he didn't see them directly. He's talking about what he heard from others. But no, people have deep beliefs about things that don't make them liars. And they've experienced something, he thinks he's seen something, but the question is, in science, we need to have evidence that we can bring us to agreement, right? Remember our two purposes for science. So if you don't have something that the rest of us can look at together, then it's just taking somebody's word for it. And I'm not saying you should automatically doubt somebody's word, but you also shouldn't automatically take somebody's word. In order to decide whose word you're going to take, whether it's Epicurus or Aristotle, you need to say, okay, well, what is the evidence for it? And in this case, we have not been presented with evidence that all of us can look at, so there's nothing that we're able to do with it from a scientific standpoint.
Okay, thank you for your answer. And I had a second question, which was, most of the stuff you've talked about if aliens are real, has been about in terms of possible descendants of current people meeting them and things like that, maybe tens or millions or thousands of years from now. So if we're all going to be long dead by the time humans encounter aliens, if humans ever encounter aliens, why should humans who are currently alive spend even a second thinking about them if we're all going to be long dead and there are many generations will pass before we even have to start considering this?
That's an excellent question, and I would say that the reason is because we as humans are naturally curious, and everything we do in science, whether it's taking pictures of galaxies with the James Webb Space Telescope, or sending a spaceship to Mars, or studying bacteria under the microscope, everything we do in science is initially done just because we're curious. Sometimes it turns out to have applications to our lives, bacteria, medical science, and so on. But most of the time, we're just curious, and so we try and learn. So I would say that would be the reason why we would be interested in this, is for our curiosity, even if we're not going to be around to get the final answers.
I introduced the initials STI. Could that possibly mean Science Technology Investigation?
I'm not sure I quite follow that. Oh, SETI.
Yes, SETI.
It's the search for extraterrestrial life, extraterrestrial intelligence, excuse me. Yeah.
Thank you.
It seems like this planet is pretty good for life. It also seems like life only evolved once. We have one common ancestor. Do you find that interesting?
So that is interesting, and it's a really good question. So I would say a couple things. It's not clear that life only evolved once. It's clear, it would seem that life only survived once, right? Maybe it had multiple starts that got wiped out in between. There are actually some biologists who wonder whether there might actually be other life that doesn't share the common ancestor, and we just haven't figured out how to recognize it yet. So we can't be 100% confident that all life shares the same common ancestor. What we know is all life that we've discovered so far on Earth does, but maybe there's another. But it's also reasonable to imagine that the reason we all share that common ancestor is because basically that ate everybody else. So if there had been other multiple starts to life, one of them evolutionarily won out, right? It ate all the other organisms and became the one that spread. Well, we have very little trace going back to the early origin of life. I didn't go into the details, but when you get to that earliest evidence of life on Earth, it's not actually fossils like you think of fossils normally, microscopic. It's isotope evidence based on carbon-13 to carbon-12 having a signature of biological material rather than inorganic material. But there's nothing to study that would even answer that question right now. it's not, it's generally not considered to be a huge issue, since there's a lot of ways to explain it.
I see one more hand. If you have any final questions, think about them now.
Thank you for your talk tonight. I have a question. You had mentioned an experience with a UFO. Can you elaborate on that?
Oh, sure. I was out on the deck with my son when he was pretty small one time, and we were just looking up, and all of a sudden, this bright spot appeared in the sky and got brighter and brighter and brighter and brighter and brighter and brighter, boom. And that's what I saw. He said, before it boomed, it shot off to the right. I didn't notice that part. Now, he was a kid, I was an adult, he has better eyesight. Maybe it did, but I don't know. I don't know who was right. It's that back to taking people's word for things. But either way, what was that? I don't know. I do know it was a meteor shower that we were out to watch. Now that's not the way meteors behave. They don't just stay in one spot and get brighter and brighter. They come shooting across the sky. But what if by chance a meteor had been coming straight down? Then it might have looked like that. So my guess is that we saw a meteor, but that wouldn't explain why my son thought it shot off to the right. So I don't know the answer to what it was. But I doubt it was an alien spacecraft. Could have been.
On the subject of seeing UFOs, there was an incident that there were four of us on our hot tub, and I happened to be, I live near the ocean, and I'm in the flight path of the airplanes as we come in. And here's one coming in very bright. Then all of a sudden, at a 90-degree turn, it disappeared over the mountains. Four of us saw that. Airplanes don't do that.
Yep. Yeah, there is no doubt that people see UFOs, but the key letter in UFOs is unidentified. And unidentified doesn't automatically mean alien spacecraft. So we don't know. You know, there's certainly strange things. If you take what I described of the aliens being so advanced, right, that their technology is like magic, you might imagine that every once in a while, they slip up a little bit and we get a glimpse of them. Maybe that's what you saw. My main argument is they're not going to completely slip up and crash in Roswell. And so we're not going to get anywhere by trying to figure out what these occasional slip-ups are if we can't collect actual evidence to do something with. If they did crash in Roswell, then we could do something with that. But they didn't. That was an Air Force balloon. So yeah, UFOs might be alien spacecraft. I'm not saying they're not. I'm just saying we're not going to get anywhere following that path to study. This path of science, I think we'll get somewhere with.
Dr. Jeff, this is the other side of the stage asking you a question. Have you heard one of the silly things that Neil deGrasse Tyson has said about Hollywood's track record on depicting in the horror movies we grew up with the alien creatures? They all had 2 arms, 2 legs, whether it was Godzilla or Alien or all the creatures in George Star Wars. What's his last name? George Lucas's Cantina. He gave thumbs up though on one accurate one. You know what movie he picked? Which might really depict what an alien might look like? I'll give you a hint. It was in the 50s. It starred Steve McQueen. Anybody know that movie? Exactly.
Yeah. One of the fun things about like the Star Wars cantina scene is, what's the odds? Even if the aliens do all look like that, what's the odds that they all got to the same level of technology at the same time, given the spacing that you would expect just randomly between civilizations? In fact, Stephen Hawking, brilliant scientist, obviously, but he said one wrong about, which was, he said we shouldn't send messages out like that Arecibo message, because if the aliens are mean, basically, and they see our message, they'll go, wow, those guys have a nice planet, let's go take it. And, you know, the reason I disagree with him on that is because, first of all, if they're able to come this far, we don't have anything they need. They can just produce it themselves a lot easier. Number two, right now, our SETI telescopes are only capable of receiving a very powerful directed signal. So somebody would have to be sending us something on purpose. But if you have much more advanced technology, you can imagine building much larger radio receivers so that you could receive much weaker signals. And so aliens who have very advanced technology, they should be able, in principle, to see any radio signals that we send out, not just the ones we send on purpose. And we've actually been sending out, not on purpose, radio and television shows for decades. And some people actually think that's why we haven't been visited. So they saw that, don't go there.
What was the first science fiction movie that made the aliens friendly to us?
That made them what?
That made them friendly.
Friendly?
Smiling, not hostile.
Do you know the answer? I don't know.
It was directed by Steven Spielberg.
Oh.
It involved the Devil's Tower Monument.
E.T. or yeah, that was Close Encounters. Well, you know, and then there's been other science fiction, 2001: A Space Odyssey. They're not necessarily friendly or not friendly. They're just way, way, way beyond us. Yeah. So yeah, science fiction writers are usually pretty far ahead of the game.
What do you think of Three Times Problem?
I enjoyed it. In fact, in some ways, I like the show better than the book. Yeah, but you know, cool stuff.
Well, I think we need a big hand of applause. It came to our attention at the club that you don't really have a decent cup to drink your coffee. We have one that's based on an ancient Jewish legend that we dug up, and I hope you don't mind. We're trying to sell our leftover stuff, but I'm going to include our honorarium we normally give.
Thank you.
So, Jeffrey Bennett will be here. Grandkids or children to that, right? 10 o'clock.
Yeah.
Is this the program you gave us tonight, the one you read the astronauts on ISS?
No, they read all 7 of my children's books. So
They read them or you read them?
no, they read them.
Oh, they have them up there on the board.
Took them up with the ISS. They're the best travel books in history.
Okay, everybody, get to know your neighbor. I'm going to close the meeting by saying come buy some of the stuff Pat McPartland is selling and listen to our podcast. It's called SBAU Astro Hour, live on Monday mornings, 11 noon on YouTube. Just enter that. And we'll see you back here on April 4th, down below next to the planetarium.